Hello, my name is Salvador Mendoza, and it's my first time here in DerbyCon, so I'm very excited to be here. I'm going to talk about Samsung Pay, tokenized numbers, flaws, and issues. I want to start with the agenda for today. We're going to talk about terminology, analyzing token numbers, MST and NFC protocols, and how Samsung Pay implements them, token phases, flaws, and issues, dangerous scenarios, Yams Pay, token get tools, some tools I made for this research, international tokens, MaxPay, a new device that I'm going to introduce to you in this tag, and other researchers. So some terminology for this tag is NFC for near-field communication, MST for magnetic security transmission. So basically, what Samsung implements is like when you are going to make a payment, you use these two protocols to have a wider vendor's terminals acceptance, different from Apple Pay, which use just NFC. BTS for Visa Token Service, tokenized numbers, which is a process where the primary account number is replaced with surrogate value, which means a token. When I'm talking about token, just think about tokenized numbers. A token in authorized voucher to interchange for goods and services, and TSP for token service provider, and PAN for primary account number. So let's analyze a tokenized number. Basically, it's the same virtual credit card. The first 20 digits and the last the first 16 digits. The last 20 digits, they are the new tokenized number, which is like an ID for that token. And you can use just one token for each transaction. So we have the separators. What they did was exactly like making a format for American Banking Association, emulating perfectly the physical swiping card. Let me show you basically what a token from Samsung Pay is. So let me use my phone. So I'm going to make a transmission. So this one is going to send the same token like 1 minute until the terminal gets the token. You have to send again the token and make another token. If you can notice, this one is kind of different with identifier right here. 32, 33 is going incremental. I'm going to add some tokens just to see the difference between each one. I'm going to make like maybe 5. Okay, just lay down. So what I'm going to do, I'm going to use a Python just to make a review of the tokens. So basically what you have here is the last 20 digits of the token. What is the difference? This one right here, it's the expiration of the credit card, the virtual credit card. The next one is the service code. We change, for example, you have a Shiba PIN protection in your car and you add it to this Samsung Pay. This one is going to change it for 101, yes, without any restriction. This one I call the BCC row, which is at the first counter. The next one is the ID transaction, and the last 3 digits are the random numbers. Basically, this is the format of the token, which is supposed to be very random, but the reality is not. So that's exactly what I tell you about each field. The difference between online and offline mode is the main difference basically is the counter in the middle. If we see this counter right here, if I put an airplane mode, I can use my Samsung Pay to make payments, but this counter is not going to change. So what is going to change is going to be just the ID for each purchase and the random numbers on the end. So what I say, you can make payments in offline mode. Like any other transaction in the banks, you go to phases. Basically, it's when you make when you create a token, it's go for some kind of status until it's get processed, like active, pending, disposed, enroll, expire after a valid time period, suspended, basically. How the system updated token. I was talking to some guys in Samsung, and they said this was not true. Basically, what they say, this kind of simulation wasn't true. But what I found in the code was, if you see the provision token or something like that, what I found in the code is they use in the tables that data to make the update. Basically, it's all the data that you need. The provision token ID, but also the API number. So it's all their information. What another thing that they say, they never save data in the storage. But also I found that the token has been retrieved from storage from MST. So I don't know what they're talking about, or maybe they don't know the framework. I found many files and directories inside of the Samsung device. It's not just because you cannot root the phone and use the Samsung Pay simultaneously. So it's impossible. But what I found was all these kind of files, they use it to make these kind of transactions and many databases. If we take a look at this database right here, in the bottom, this database we're attacking right now. It has all information. I'm right now in the Visa framework inside of the Samsung Pay. Let me take a look at the. Basically, Samsung Pay use this framework on the top to complement the another package. They are separated to make the tokenization process. So another flaw and issue that I found was in the databases. Maybe they're thinking these databases are encrypted, but what I found was like in substitution characters inside to in this case to encrypt the databases, and they have the static passwords and the functions. But it's not yet for the databases by itself, but also for another functions. I was thinking maybe possible for the network encryption, but I cannot say it's true because they are going to say it's a fallacy. Another flaw and issue that I found was when I was able to make a backup of databases, I found that a token expiration field in the database wasn't blank. That means something was wrong here. Also, they will try expiry time, implement timestamp format, but it was for 1 day. So what I noticed was, for example, if I ask you, hey, can you show me how Samsung Pay works? And you just show me how Samsung Pay works, and Samsung Pay is generating 1 token, but you're not using that token to make a purchase. Just you're generating that token just to show me how Samsung Pay works. The next time that you are going to make a payment, you're going to generate a new token, but the last token is still alive, still active. So anyone else can use it to make a purchase.
So those tokens you just showed us on the screen.
Exactly, they are active, but don't use it, man. Yeah. So another issue and flaw that I found was when I delete my card in Samsung Pay, the new virtual credit card is almost the same. But I tried to do it in different days. I tried to make a log and everything. So what I found was that the last 4 digits what will really change in a period of time. So but how you can get the last 4 digits, just you need to, and you are going to get it from the side of the card without any password or something, you have a physical access to the phone. So if someone can get the token, maybe he can guess the next 4 digits. So let's go to the good things about the attacks. One of the things I was thinking about is to reverse the encrypt and decrypt functions. If someone is able to do that, if if one person can found a 0-day and knots, for example, it's going to be able to reverse the databases and information from Visa, for example, for MasterCard, American Express, or any other bank. Also, I designed a token get. My token get baby is a device that you can put in your arm, okay, where under your code, and you can use it to detect tokens. So basically, what I did, I have this device under my code, and I'm going to use it to generate token. Oh, I can see it. Basically, it's the light of my credit card reader. So what it does, it sends these tokens to my email, so I can use another device like MaxProof from Samicam Car to make a purchase. Basically, you can see in the background how they are loaded. After that, I load these tokens, one of the tokens, to the MaxProof device, and I'm going to a machine and try to make a purchase. So basically, I select the product and it validates the token. What Samsung said that it was impossible because you need many things from the phone to make this purchase. So the next device was JamsPay. JamsPay is a new device. It's the same thing, but this device you can put in the terminal, closer to a terminal. So basically what it does is the same thing. You can just leave it in the terminal, and a person comes to the terminal, try to make a purchase, and it sends this token to the email. But I improved this tool, and you're going to see in the next videos. It's going to have a Python web server, so you can control the service inside the computer. By basic, what you do is like the person is going to make a purchase, but it's jamming the terminal, sending signals to a terminal using MST, another MaxProof device inside of the same bots. So it sends signals to the terminal. When the person is going to make a payment, the terminal is not more in input mode, so it is not going to detect the new token. So basically, it's going to detect the token sent to an email, so I can get it and use a Samicam card device, MaxProof, and make a purchase. So the next, so let's try to guess a token. What I'm going to do is I'm going to put my phone in airplane mode. And I'm going to start capturing tokens. That's one. And you will notice the counter in the middle is not going to change anymore. So basically, you see here in the middle, this counter is going to be in the same position ever. So this is going to be incremental, and the last ones is going to be random numbers. So what really you need to guess is the last 3 digits, basically. They say it was impossible, this is not going to happen, or all that kind of things, but there really is a problem here. International Samsung Pay tokens. I was thinking that it was possible to use these tokens in another country. Maybe I was thinking that they have some restrictions from the physical credit card to the virtual credit card. So I sent one of my tokens to one of my friends in Mexico. Samsung Pay is not in Mexico yet. So I thought that maybe this one is not going to happen. But what it says, hey man, can you check this out and try one of my tokens in Mexico? He's charging me 20 Mexican pesos. So it's making a transaction. The transaction went through. sign in. There you go. You have 20 Mexican pesos from me, man. So basically, I got the notification. I got a notification from Samsung. Hey, here in the bottom, you spend 20 Mexican pesos where Samsung Pay is not in Mexico yet. What they say about this was because Mexico is too close, it's kind of United States, so. So I want to introduce today to DerbyCon the MaxPoof Pi. This MaxPoof Pi is a new device from Raspberries. So basically it's the same thing like MaxPoof, but you have the opportunity in this case, like you can use the Raspberry to have variable tracks on it. For example, why I did this kind of project was because I was need to update the token every time I need to use it. So I designed this project and a Python to start changing the tracks when I want it, or in the way that I want it. Also, you can change the bar rate, all that kind of things on it. So I made a video. This one was the first prototype. I'm using a Raspberry Pi 3, LipoVary, and Power Boost, USB cable, MaxPoof. Everything is on internet. You can find all the project on internet. So I made a video here in DerbyCon, of course. So basically what it does is like, I'm using Python just to test it, to see what is the actual token. I have a timer, so it takes a while to start transmitting. Basically what it does is like, it's exactly like a Samicon card device. The same thing. After that, I'm going to use my Samsung Pay device to update the code. So I start compiling all the things and updating the code to the project, even without removing, that's the main point, removing from the Raspberry. So it's updating. It takes a while because, it's like a microchip. But after that, it's ready. What I noticed was when I tried to use this device in the video, I was trying to use in the backwards, and it didn't work. You can see right here. The coil's on our side. So I turn it over, flip it. I was like, what's going on? But yeah, after a while, I'm going to get it. So that's a new project I'm going to use for this research in the future. So another researchers, I found that I'm not the only person who is researching about Samsung Pay. After my tag on DEF CON and Black Hat, I found that there were some guys in Asia that were researching about this issue. What they found was, I was thinking about it, but I never had the opportunity to do it. You can sniff the signals for even almost 2 meters using a coil. Using a big coil like these ones. So it's kind of, maybe you're going to use that one. You're going to say pizza bots, Turn it with you. Yeah. So basically, it's possible. It's there. It's a possibility. So the takeaways for this tag is about it. Samsung Pay has some levels of security, but it's a tag that could be targeted for malicious attacks. Samsung Pay also has some limitation in the tokenization process, which could affect customer security. And finally, tokens generated by Samsung Pay could be used in another hardware. Please, do you have any questions?
Is it different for each phone, or is the encryption key consistent like the password?
I think they are used. He is asking about if the encryption for the databases basically is different for each phone, or just for one specifically phone. What I found was that this code, the static password for databases, to encrypt the database is the same for each phone. I mean, it's the same for each phone because it's a static password.
No other token or salt or any other nonce that's unique to the phone?
It depends. If you're talking about the encryption of databases, it's just the same function. They use the same function.
My next question then is, does that, if I root my phone after I've already had Samsung Pay, does that wipe the database? Does that change the database?
After you root your phone and you're going to try to use Samsung Pay is going to detect. It's going to detect it's a root phone and it's going to delete everything.
The database is still there, right?
Yeah, probably yes.
So it's possible then that I could write a piece of malware that could be put on a rooted phone that already has a database, and I can extract the contents of the database.
Probably yes.
Because the encryption is the same, I can then decrypt it from 100 million Samsung Pay phones.
Probably yes. I'm not going to tell you yes, but yes, probably yes.
Is the token only authorized for particular amounts?
No. You can. Yes, you can. I saw people buying like 2,000 using Samsung Pay, and people buying $1 using Samsung Pay. So I'm not telling you that you can buy a car, but you can buy expensive things with it. Yes.
In the scenario where you're capturing the token over NFC by the vending machine, does that purchase still go through that they tried to make, and you can reuse that same token, or are they doing it multiple times?
No, basically, it's not NFC, it's MST, what I'm talking. So what the device does is, the device is going to, in this particular case, my device is going to send MST signals using MaxPoof. So when the people is approaching to make a purchase, this terminal is busy doing my, in this case, validating my token that I'm sending using my MaxPoof. So when this person came to the machine and tried to make a purchase, the terminal is so busy that it's not going to detect that token. But the schemer on my device is going to detect it, and it's going to send it to my email.
Okay. Is it feasible to pull off something like that with the NFC?
Yes. I saw some tags in Black Hat last year about how to attack NFC. So it's possible. I mean, you need a lot of devices to do this, and but the possibility is there. Yes, back there.
You said that the app has root detection, right?
Yes.
Have you looked at trying to reverse engineer it since it's making K? You could kind of unpack that, get rid of the thing that does root detection and locate the K on the phone?
It's silent. I mean, it's very silent. It's not yet like, because Samsung Pay has a very restricted system. In this case, it's not just the system, it's also the nodes on the top. So mainly this application is under the layers. It's not yet normal application. Yeah, exactly. So that's the main protection of this kind of devices. That's why I think they are using obscurity for security in this case, basically. What they're doing. Yes, sir.
Last question, we'll stop bugging you. Do you need root to read the database?
I never try it, to be honest. I never try it. But what I found was when you open the Samsung Pay device, it's rooted, everything is going to delete it. But I never try to pull the database because my research was just to try to find the ways using a normal device and try to find vulnerabilities. I never tried to root it or something like that.
So you were able to view all of this without rooting your phone?
I reverse the application basically. Yes, all the files that I show you, it's in the code. APK. Yeah, exactly. All the structures are from the code, and there are many structures. Anything else? So I need to say thank you to these guys. They really help us a lot. And thank you guys.